Here's a problem from 1992 under the category number theory. So it's find the smallest integer n such that 14n is a perfect square and 21n is a perfect cube. And it wants us to leave our answer in simplest form with powers. So for a number to be a perfect square, its prime factorization has to have even powers. So what that means is that, for example, 2 to the 4th times 3 squared times 5 to the 6th is a perfect square because you can just write it as another integer squared, which is 2 cubed times 3 times 5 cubed whole squared. But a number like 2 cubed times 3 squared times 5 to the 6th isn't a perfect square since the coefficient of that 2 is being raised to isn't even. And similarly, for a number to be a perfect cube, all its coefficients have to be divisible by 3. So 2 to the 6th times 3 cubed times 5 to the 12th, for example, is a perfect cube because you can write it as 2 squared times 3 times 5 to the 4th whole cubed. So how does this help us? Well, if you write n as its prime factorization, so for example 2 to the a1 times 3 to the a2 times 5 to the a3 times 7 to the a4 and ... then the 14n is just 2 times 7 times n. So you add 1 to each of those coefficients. So then you have 2 to the a1 plus 1 times 3 to the a2 times 5 to the a3 times 7 to the a4 plus 1. And then similarly, we have that 21n is equal to 3 times 7 times n equals 2 to the a1 times 3 to the a2 plus 1 times 5 to the a3 times 7 to the a4 plus 1. Okay, so for these numbers to be a perfect square and a perfect cube, they have to satisfy some equations, which are that a1 plus 1 is divisible by 2, and a1 is divisible by 3, because 14n has to be a perfect square and 21n has to be a perfect cube. So if we look at these terms. And then, similarly, we have that a2 is divisible by 2, and a2 plus 1 is divisible by 3. And a3 is divisible by 2 and 3. Here and here. And then finally, a4 plus 1 is divisible by 2 and 3. So for the first thing about a1, the lowest positive integer that satisfies that is 3. So a1 equals 3. And then for the equations about a2, the lowest positive integer that satisfies that is actually 2. So a2 equals 2. And then a3, the lowest positive integer that satisfies that, actually it doesn't have to, it can be 0 also. So a3 is just 0. Because you can have 5 to the 0 power, it's just 1. And then a4, so you can't just say 0 for a4 plus 1 again, because it has to be a positive number since a4 is greater than or equal to 0. And the first number that's divisible by both 2 and 3 is 6, so a plus 4 plus 1 has to equal 6, which implies that a4 equals 5. So when we write out n again, it's 2 to the a1, and we know a1 is 3, times 3 to the a2, and a2 is 2, times 5 to the 0 times 7 to the 5th. And the 5 to the 0 is just 1, so you have 2 cubed times 3 squared times 7 to the 5th. And that's the answer.